we're going to go over a couple problems again. Hopefully yesterday's assignment wasn't too crazy. You were able to get to the Desmos. Now today is just going to be a straightforward ed puzzle that I'm going to make sure you answer specific questions out of it to get your credit. Okay. Tomorrow should be possibly a Nearpod, and then Thursday will be a quizzes. Okay? No Google Form quiz this week, just the quizzes. Complete everything to get your extra credit, guys. Let's go. -4. We start this problem off here. We look at the equation. We start here with our y-intercept. We go -4. We put our point right there. I know, the big point. Then we go up 3 over 1. Up 3, 1, 2, 3 over 1. And if we wanted to be super precise, we do it again. Up 1, 2, 3 over 1. 1, 2, 3 over 1. All right? And then here, and then kind of just draw, oh, come on. Draw your line. All right, the next one, we start at +3. +3. Down 1, the negative always applies to the numerator, over 2. Down 1 over 2. Now we're already done. We see that they both connect at a certain point. It's pretty easy to see where they touch, okay? And that's when you graph a system. That's what you need to know. You need to know, where does X mark the spot? We do a lot. All right, and if I look at this, it's pretty easy to see it's over 2, up 2, okay? Number 6 has something a little special with it. That's interesting, and we're going to graph both of these just like we normally would again. Number 2 or number 6 here, the number 2 that we're going to do here. Now, so we're going to start with +2. Put a point here. I'm trying to use my stylus. That didn't work. +2. And then we're going to go down 2 over 1. Down 2 over 1. We're going to keep doing that, okay? And then if I go down 2 over 1, I can go up 2 to the left 1 and create the same line. All right, let's get the ruler out. And there's my line, okay? Now, if I'm looking at this, I got to do the next one, and you're going to see something interesting. I'm going to go -2 right here. And then I'm going to go down 2 over 1. Now, instead of down 2 over 1, go up 2 to the left 1. Up 2 to the left 1. Up 2 to the left 1. Okay? And when I draw this line, I want to know, where do these lines touch? Do they ever touch? No, they never touch. When they never connect, ever, remember this? All right, no solution. And what do we notice about our two lines here? What do they have in common? They don't have the same y-intercept. They don't have the same y-intercept, but look at the slopes. The slopes are both -2. So when you have something that has the same exact slope and different y-intercepts, that's no solution. What would this one mean? Remember this one, infinite? Infinite would be same slopes and the same y-intercepts if these are the same, if this is a +2. So if I wanted to go crazy and say, all right, this is the same exact equation and I made this a +2, then you would have graphed the same line right on top of each other and it would be infinite solution, okay? So no, when they're the same slopes. I know that looks terrible, but just remember that concept, okay? It is kind of a tough idea to think of sometimes. All right, now let's go to this one here where it says, now we have a word problem. Interesting. It's all good. You're going to be just fine when you look at these, okay? 2 skaters are racing towards the finish line of a race. Okay, we can put that in our brain. The first skater has a 40-meter lead and is traveling at a rate of 12 meters per second. The second skater is traveling at a rate of 14 meters per second. How long will it take for the second skater to pass the first skater? All right, so this one is a little intense. What's the first piece of information? We have 2 skaters. The first skater, we're going to deal with that, has a 40-meter lead. I will help you with what that actually means, okay? And then what happened here? We got to get this part. Okay, cool. Now, this 40-meter lead, oh, I can do better than that, is very important to look at and is traveling at a rate of 12 meters per second. So if you remember the turtle lesson from the Desmos, a lead meant that that's the y-intercept, where it is on the y-intercept. And what I don't like about this, this graph, and all I'm going to have you guys do right now is just look at this. We're going to do it together, but I'm going to graph this, and really my equation should look like this. Y equals 12x plus 40. And that's what it would look like. The 40 is the y-intercept, where my starting point was. And the 12 meters per second, that's my slope, okay? So the 40, if I was to plot this, this is going up by 2s, but they're going up by 25s, right? Up 25, another 25. So then if I go here, this is 25, this is 50. What's half of 25 and 50? That would be probably like 37.5. So we're going to say 40 is like right here. All right, I'm trying to get super precise here. I know it's not great, but it's okay. 40. Now, we're going up 12 over 1 every second. I'm going to go ahead and just graph this for you a little bit so you can see what's going to happen. If I was to go up 12 over 1 second, but look what this is written out as. Are you writing them out as 1 seconds? No, it's after actually 2.5 seconds and 5 seconds. So you know what I'm going to do? This is kind of crazy, and I want you to see what I'm going to do right now. This is my x, right? This 5. I'm going to plug in 5 right here for my x. I just want to see a challenging problem. I want you to see how it's presented to you, okay? I'm going to plug in 5 because after 5 seconds, I want to know where I'm at with this equation. And I know that 12 times 5 is 60, okay? And then I know 60, I'm just going to add that 40 is 100. So y equals 100 when 12, or when my time is 5. It's a little confusing. It's okay. So let's actually go to y equals, at 5, we're going to go up to 100. And what I'm going to do here, I'm going to say, okay, this equation, this was from the book too. Sometimes the book just annoys me because they try to give you problems that are super challenging instead of just kind of warming your brain up to the idea. So it's okay. We're going to get through it. And then I'm going to make my clean line right here. Okay. No big deal. We're good. Why did I start here on the y-intercept? Because it's a 40-meter lead. That's super important that you understand. Okay. Now the second skater is traveling at a rate, I'm going to do a different color, of 14 meters per second. And it doesn't tell me about any lead. So if that's the case, we're going to start right here, right? There's no lead. So we're just going to talk about starting at 0. And then it's going up 14. And again, this is interesting because we're going to be like, okay, 14 meters per second, your equation will look like this. Y equals 14x, right? But what if I now plug in my 5 again here? And what's 14 times 5? 70, okay? So that is interesting. We're going to use that knowledge right now. So y equals 70. At this right here, we're going to go, remember this is 50 to 75, it's going to be right about here, okay? Oops. Now, let's go ahead and get my ruler out, and let's see what we can do here. I know this problem's kind of crazy, but again, sometimes you have to look at certain problems and do the best you can to solve them. And look at this. Look at the data we have here. The red line and the blue line. And which one would you say is steeper? Which one has a bigger slope, a steeper slope? And if I look at this, it's the blue one. It's 14. But the 12, it was going up so high because we started at 40. So it's a little steeper. It's not, these are not parallel lines because they do cross. Now, what would you say after what time? How long would it take for the second skater to pass the first skater? I would say right about here in this range, which is how long? Close to about 30 seconds. Okay. So do the best you can with these kinds of questions. I know it was kind of tough initially, but we can get through it. You can try to give me a pretty accurate answer just by struggling through it. All right, let's take a look at this one. Where are we at here? All right, cool. This one's going to be a little easier to deal with, and that's what should happen. Our textbook gets a little crazy, so this one I've actually pulled from online. Today, the temperature in New York is -1 degree, and that does happen, but not recently. Usually more wintertime. The temperature in New York is -1 degree, and is expected to rise 3 degrees per day. Interesting, this word per day. Okay, we have to take sign of that, and we're going to now first deal with this part. And I've talked about y equals mx plus b, where this is your y-intercept, and this is your slope, okay? The m is your slope. And we're going to go ahead and write this equation out, okay? So let me just delete everything again. -1 is the starting point. Starting point, I always call the y-intercept. So -1's here. And your slope is what it's rising. It even tells you rising 3 degrees per day. It's a rise or it's a fall, okay? And to write the equation out, you would write y equals, what's your slope? The slope goes first, 3x, and then your y-intercept goes second. You have to know that for high school. Again, your y-intercept, your slope. Y-intercept, slope, okay? Now let's do the second one. It's 6 degrees in Alaska, and it's expected to fall 1 degree every 2 days. 1 degree every 2 days. This is kind of tricky, actually. They are trying to mess with you a little bit. What's the starting point? 6. All right, and it's going to go down 1 every 2 days. How could you write that as a decimal? -1/2. Could you write it -0.5? Isn't that the same as 1/2 as well? So you could write your equation both ways. You could go -1/2 x, which is what we're more familiar with looking at, or that could have been -0.5 x too. Either way would have been the correct answer. Okay, so now, all right, now this is part of the problem. Let's take a look at this. It says we're supposed to graph these. So let's graph the first one. -1. It's going to go right here, right? This is New York. It started at -1 degrees, and it's going up 3 every day. So up 1, 2, 3 over 1. 1, 2, 3 over 1. And it's hard to see, but you get the idea. And the slope is actually 3. So let me get the ruler out. Handy ruler. Try to line these up the best we can. All right, that's pretty good. And there's my line. Okay. Now, let's go ahead and do a different color. Let's do, I forget what city it was, the other one, but let's do the other one. It was going to be +6. 1, 2, 3, 4, 5, 6. It's going down 1 over 2, down 1 over 2, down 1 over 2. And you should see right away, it is going to connect. They are going to touch. And if I do this properly, you should ask, after blank days, the temperature in both cities will be blank. Okay, after how many days will the temperature in both cities be what? So after how many days? And if you realize, we didn't really mark our x-axis, but this part here, our x was actually called days, okay? And then our y was temperature. So days is x, so this is days. So how many days? Over 2? After 2 days, and you go up, our temperature will be at 5 degrees. All right, that was kind of tough, but you guys can get through this. It's fine. And then don't worry about the strong answer right here. We'll move on from this, and let's take another peek. What's going on? All right, now we're going to finish up real quick, just looking at a couple problems here. Let me get over here. A system equation that has no solution, what does the graph look like? Intersecting lines, parallel lines, skewed lines, intersecting lines. Well, we know parallel. You should know that. Okay, let me hide this answer here. Next one. What is the solution here? Over 1, down 1. Okay, don't get too confused. You should know. Okay, good. We got that one here. What about, what it says? What does it say here? When you graph the exact same equation twice, you will have infinite answers. All these spots on the line would be points, okay? And let's just do one more. Let's see. We know that one is, okay, so where were they touched? That's the answer. Over 6, up 3, and that would be your final answer. All right, do the best you can on this, on the quizzes for Wednesday. or actually Thursday. That's the end of the week. And it shouldn't be too tough. You'll be just fine. All right, guys, great work. Keep up the good work. Call me or let me know if there's any